Hybridization, and we were talking about carbon atom. What we were talking about was that when an atom bonds, uh, we had previously talked about sigma and pi bonds, that atoms are pulling electrons from other atoms. So the electrons kind of get pulled in different directions, which is why pi bonds are formed. Like this atom over here, this oxygen atom over here, needed electrons, so it started pulling the electrons from the other oxygen atom. So they ended up overlapping above and below. So atoms, they pull electrons from other atoms, and which is why the electrons kind of get stretched in different directions. And when that happens, the orbitals are going to change shape. So we had started talking about carbon atom. We had started talking about and hybridization is only for in your syllabus. You're going to study the hybridization of carbon atom only. So the carbon has four electrons, the 2s, the 2px, 2py, and the 2pz. Each one of them has one electron each in each of the orbitals. What happens is that all these orbitals need one electron. So they would be pulling electrons from other atoms, and other atoms would be pulling electrons from them. So if carbon bonds with four hydrogens, it's forming four single bonds. The electrons get pulled in different directions. So previously you had an electron in an s orbital. The electron was buzzing around in a spherical region. There was an electron in the 2px, which is let's say this one. An electron was buzzing around in this area, and then one electron was buzzing in this area. Similarly, one electron was buzzing in the 2pz. So you had electrons in the specific spaces around the nucleus. But when it bonds with other atoms, the electrons kind of get stretched, pulled in different directions. So, so the region that the electron is going to occupy is going to change. For example, one of the electrons is going to it's going to be pulled towards hydrogen. One electron would be pulled towards hydrogen. So the electron would be stuck somewhere in this area, buzzing around over here, because it's being attracted by the nucleus of the hydrogen atom. Similarly, a third electron gets pulled over here, a fourth electron gets pulled over here. So all the orbitals, they change shape. So what you do is you stop calling them the 2s, 2px, 2py, and 2pz, because 2s, 2px, 2py, 2pz, they refer to a very specific shape. Assalamu alaikum. So they refer to a very specific shape, uh, but that shape is now gone. So you still have an orbital, you still have four electrons, except that you have to give that orbital a different name. So instead, because all four that now look kind of identical, so you give them the same name. You've got an sp3 hybrid orbital, sp3 hybrid orbital. This one is sp3, this one is sp3 as well. And you start calling them. This is known as sp3 hybridization. That the four orbitals have now changed their shapes when they're bonding, due to the attraction of the four hydrogen atoms, or any of the atoms, if there are four atoms. So this arrangement is known as a tetrahedral arrangement. And the angles are 109.5 degrees. I'll show you the shape as well. Maybe it's a, so tetrahedral carbon atom, just 1 second. So this image is this one is good enough to give you an idea of what a tetrahedral arrangement is. So the four electrons have been pulled in four different directions, and one electrons getting pulled in this direction, over here, over here, over here. So that is sp3 hybridization, and sp3 hybridization happens. Uh, and let me label this. So this one is the first one, that's sp3, and it happens when carbon is bonded to four atoms. And it happens when it forms 4 single bonds. As the next hybridization we're going to talk about is sp2 hybridization. And again, we're talking about carbon atom. So sp2 hybridization is when carbon is, you can say when carbon is bonded to just 3 atoms, or when carbon is it's making 3 sigma bonds plus one of which is going to be a pi bond. Or you can say it's making, in other words, it's making 2 single bonds and 1 double bond. The easiest is when it's bonded to the 3 atoms. So for example, you have carbon making a double bond with oxygen and 1 bond with H, 1 bond with another H. So that is clearly sp2 hybridized carbon atom. Uh, you got an ethene molecule. In that case, carbon is also bonded to just 3 atoms. The other carbon atom is also bonded to 3 atoms. So it's making this carbon atom is making 1 double bond, one single bond and another single bond. So 2 single bonds, 1 double bond. Or you can say it's making 3 sigma bonds. Remember, the first bond between atoms is a sigma bond. If there's a double bond, that's your pi bond. So there are 3 single bonds, 3 sigma bonds, and one of which is going to be a pi bond. There's going to be an additional pi bond over here. So what happens in this case? Now in this case, what happens is, again, carbon has 4 electrons in its outer shell. It's 2s1, 2px1, 2py1, and you've got 2p Z1. So you've got these 4 electrons. But right now, if you look at carbon, around carbon, they are just 3 atoms. So I'm going to so they're just 3 atoms. So that means that only 3 of the electrons are getting pulled in different directions. So one electron gets pulled towards oxygen, the other one gets pulled towards hydrogen, the third one gets pulled towards another hydrogen. So 3 electrons of carbon get pulled in different directions, and they end up forming 3 sigma bonds. So that's initially what's happening. So 3 electrons. So I'm going to mark those 3 electrons, and they get pulled in different directions. The fourth one kind of remains unchanged because there is no fourth atom. There is no fourth electron. No one is pulling this fourth electron or attracting this fourth electron. So the fourth electron remains exactly as it was. So there's an electron that's buzzing in this area, and no one is initially interested in that electron. So what has happened is 3 of the electrons have changed shape. Instead of being in a spherical orbital now, the electron of the carbon atom got pulled towards oxygen. Instead of being in a px orbital, the electron got pulled by another hydrogen atom. Instead of being in a py orbital, the electron got pulled towards another hydrogen. So that's 3 electrons getting pulled in different directions. So you start giving them different names. Instead of calling them 2s, 2px, and 2py because the shape has changed now, you start calling them sp2 hybrid orbitals. Because the orbitals have now changed shape. The electron is now existing in this area over here. This electron over here is existing in this area over here. This electron over here has been pulled towards the hydrogen at the top. So all three electrons got pulled in different directions, and all three electrons are now existing in different spaces around the nucleus. They got pulled in different directions. Is this clear?
Yes, sir.
Okay, so one electron, so all these three electrons got pulled in different directions because there are three atoms bonded to it. The fourth electron, nothing happens to it. So what is happening to this fourth electron? What does this fourth electron do? So if I draw an ethene molecule, uh, this is what's happening. Three electrons get pulled in different directions. Uh, and what are the three atoms? There's an H over here, there's an H over here, and there's a C on this side. The other carbon atom, exactly the same thing happens. Its electrons get pulled in different directions. So there is an H, another H. So each carbon atom, three electrons are busy. One over here, one on the top. The fourth electron at the moment is not doing anything. And this carbon atom, the fourth electron is not doing anything. When you have two orbitals that are parallel to each other, they would end up overlapping with each other and they would start forming a pi bond, because remember the fourth orbital also needs an electron. There is room available, so both carbons would try to pull each other's p orbital towards themselves, and eventually what would happen is that the electrons would start overlapping and they would now exist in the area that's somewhere in between the two carbon atoms, and they would end up forming a pi bond. So that's where that's why bonds happen. Three electrons form normal bonds. The fourth electron, that's not busy initially, ends up forming a pi bond. Is this clear? Yes or no? Is this clear? Mariam, is this clear? Alicia,
Yes,
Anna, clear?
yes, sir. Yes, sir.
So now the next thing is, so that is sp2 hybridization. So we're done with sp2 hybridization. All you have to know about sp2 hybridization is that remember these three bonds, the normal bonds. Forget the pi bond at the moment. The normal bonds, they're fan shaped. It's called a trigonal planar arrangement. So these are trigonal planar. Which in simple English is fan shaped, just like a fan. The three electrons are getting pulled in different directions. Uh, the angles are 120 degrees in this case. Okay, that's the shape. And it is planar. It's like a fan is a completely flat molecule. I mean, it's a completely flat shape, a two-dimensional shape. So this is also two-dimensional. The pi bond is actually above and below the plane. It's going to look something like this. Like if I show you, and let me show you ethene. Uh, maybe if there's a better version of this, just 1 second. I think this is. So let's have a look at this one. All I wanted to show you was that think of this as a fan. The p orbital is on the z-axis. Like if this is in the xy plane, the fan is like lying flat. The three orbitals getting pulled in different directions. The sp2 hybrid orbitals. The fourth electron, the p orbital is it's completely on the z-axis. So the fans would be overlapping. They would form a sigma bond over here, and they're going to form a sigma bond with the hydrogen over here, with the hydrogen over here. The p orbitals that were not being used initially, they would end up forming pi bonds from the top and the bottom. So just to give you an idea of what the shape is going to look like. I think, I mean, this image was probably good enough. So let's move towards sp hybridization. That's the last one. Now, what's sp hybridization? As a previously, I think I did tell you that three of the orbitals would change to sp2, so that's fine. Now, what happens in sp hybridization? Sp hybridization is when the carbon atom is just bonded to two atoms. And it's bonded to two atoms. So what that means is that it's forming two sigma bonds and it's forming two pi bonds. Or in other words, it's either forming two double bonds or it's forming one single bond and a triple bond. Plus one triple bond. So I'll give you examples like, I mean, the best way to judge is that whenever carbon is bonded to two atoms, that is basically sp hybridization. So you've got two double bonds like a carbon dioxide molecule. That's a carbon atom that's making two double bonds or just bonded to two atoms. Or it could be an HCl molecule. Now in an HCl molecule, carbon is only bonded to two atoms. So whenever carbon is just bonded to two atoms, that's sp hybridization. So what happens in it? Carbon is bonded to two atoms. What happens in sp hybridization? So carbon, remember, has four electrons. It's got this 2s electron in the 2s, a 2px, a 2py, and it's got a 2p Z as well. So I'm going to draw the molecule of HCN. So just to show you what happens in sp hybridization. So carbon is only bonded to two atoms. That means one of the electrons is going to get stretched in one direction, the other electron is going to get stretched in the other direction. So there's going to be an H and there's going to be an N, right? So two electrons, two of the orbitals have, or two of the electrons in these orbitals, they've changed shape. One of them got stretched or got pulled towards this H. The other one got pulled and got attracted towards this N. So two of the orbitals have changed shape. So if they've changed shape, you give them different names. You start calling them sp hybrid orbitals. Whereas two of the orbitals have nothing has happened to them because there's no third and fourth atom. They're just two atoms. So that means there's a 2py. The 2py orbital would be on the y-axis. So there's one electron that's buzzing around in the 2py. And there's going to be a 2pz as well. So we've got a 2py. And on the z-axis, there is going to be a 2p z. So there's an electron that's, I mean, there's still two spare electrons available. So initially carbon's only, out of the four electrons, one electron got pulled over here, one got attracted over here. The third electron and the fourth electron, they're still buzzing around in their own orbitals. Now remember, nitrogen has spare orbitals. Nitrogen, if you look at electronic configuration of nitrogen, that's the outer shell is 2s2. Its 2px is empty, 2py is empty. and it's got a 2pz that's also empty. Nitrogen has three orbitals that need electrons. Nitrogen has already received one electron from carbon. It got one electron, so the 2px is, let's assume that's full. What about the 2py and the 2pz? So what's happening is nitrogen has orbitals that still need electrons. So there's a 2py, and on the z-axis there is going to be a 2pz as well. So you've got two orbitals, spare orbitals of carbon, the 2py and the 2pz, and you've got a two orbitals for two spare orbitals of nitrogen as well. They both need filling up. I mean, they both need electrons. So they would start pulling each other's electrons, and they would start forming. They would start forming pi bonds. So they would start attracting each other's electrons, and a pi bond is going to be formed. So there's going to be a pi bond that would be formed above and below. So that's the 2py bonding with the 2py. These two have ended up overlapping with each other. So they've started sharing electrons. The final one that's left is the 2pz. You've got a 2pz orbital, and there's a spare 2pz orbital over here as well. So the two 2pz orbitals, they would now start overlapping with each other. So they're going to start overlapping in front. So they're going to start overlapping in front. And they would also overlap behind on the backside. So this is what's happening. I'm just going to give you a brief recap of what's going on. What initially started off with was carbon bonding to two atoms. So one of the electron got stretched in one direction, the other electron got stretched or pulled in the other direction. So carbon, one electron went here, and one electron was attracted by hydrogen. So carbon ended up making two bonds with two of its orbitals. The other two orbitals needed electrons, but no one was initially attracting or giving them electrons. So carbon had a spare p orbital that needed electrons, and carbon had a spare z orbital that needed electrons. Nitrogen, on the other hand, also had three orbitals which needed electrons, but one of them did receive electrons from carbon. So one was gone, so it had two orbitals remaining that needed electrons, a 2py and a 2pz. And so they started overlapping with the carbon's spare orbitals, and they ended up forming two pi bonds. So there was a pi bond that was formed over here, and there was a pi bond that was formed. One was formed at the top and the bottom, and the other one was formed behind and in the front. So there's a triple bond that's being formed over here. The middle one is a sigma bond, plus there are two pi bonds. So it's H, and over here there's a triple bond. The C and N have a triple bond. So is this clear?
Yes, sir.
ठीक है, is this Anna, is this clear? Anya, is this clear?
Yes, sir.
Abdullah.
Yes, sir.
So Abdullah, just a quick recap. Remember, this is confusing. Let's keep things simple. Abdullah, is this clear that carbon had four electrons, right? And each one of those electrons, they were just buzzing around in their own spaces, right? Abdullah, is this clear? So what then started happening was that other atoms, they came along and they started pulling those electrons. Like hydrogen needed one electron, this hydrogen needed one electron, this hydrogen needed one electron. So four hydrogen atoms came along, and carbon had these four electrons that were buzzing around in their own spaces. But now one of them got pulled in one direction, one got pulled in one direction, the other one. So they all got pulled in different directions. So the electrons are now buzzing around in areas that are different from the ones where they were initially buzzing around, right? So the orbitals have now changed shape. the electron is now stretched or pulled towards this hydrogen atom. This electron got pulled and stretched towards this hydrogen atom. So all four orbitals, I mean these ones over here, they have now changed shape, and you start calling them different names, right? Is this clear? The first one.
Yes, sir.
So that's how the carbon atom would look like. There won't be any spherical orbital when carbon is bonding. There wouldn't be a double, like the electron wouldn't be just buzzing around in this area when it is bonding. One electron goes upwards, one gets pulled by this atom, one gets pulled one over here. So that's tetrahedral, that's sp3 hybridization. What you just need to remember is, I mean, no one is going to ask you for an explanation for this. What you just have to remember for this is, when does sp3 hybridization happen? It happens when carbon is bonded to four atoms. Whenever carbon is, sorry. So when does it happen? When carbon is bonded to four atoms. What is the shape of sp3 hybridization? It is tetrahedral, and the angles are 109.5. Then about sp2 hybridization, you might be asked to draw some of the pi bonding that's taking place. So I'm just going to recap this. sp2 hybridization is when carbon is only bonded to three atoms. Now it can only bond to three atoms if it's forming a double bond. So there's definitely going to be two single bonds and one double bond in most cases. So whenever you see a carbon atom that's only surrounded by three atoms, that is sp2 hybridization. What that basically means is that carbon had four electrons. Now, so carbon had four electrons. One electron got attracted by this hydrogen, one electron got attracted by this oxygen, one electron got attracted by a hydrogen atom, or over here in ethene. Out of the four electrons, one electron over here, one electron went here, one electron over here. So it's fan shaped, right? So three of the orbitals and their electrons, like one electron over here, one electron, one electron. One went here, one went here, one went in that direction. So they've changed shape. You start calling them sp2 hybrid orbitals because the shape is now different. The electrons now exist in some different area. Abdullah, is this clear?
Yes, sir.
And what about the fourth orbital? The fourth electron is still in its original p orbital because there is no fourth atom. But the other carbon atom was also identical. It was also bonded to three atoms, so three electrons went in different directions. The fourth electron is just buzzing around on the top and the bottom. It's buzzing around in this area. So when two orbitals are parallel to each other, both atoms would try to pull each other's electrons, and the electrons would sort of start overlapping, and they would start overlapping above and below the axis, and they would end up forming a pi bond. So is this part clear?
Yes, sir.
And the last one is confusing because in the last one, in sp hybridization, I mean, drawing the diagram is out of the question. You can't really draw this diagram. It's a three-dimensional diagram. You can't be expected to draw this. So what happens in the last one? In sp hybridization, carbon is only bonded to two atoms. That's it. So if carbon over here in the center, it's bonded to... One second. So carbon over here in the center, it's bonded to two atoms. So two of the electrons are already busy. One electron got attracted to nitrogen atom, the other electron got attracted to the hydrogen atom. Now nitrogen wanted to fill its orbitals because three of its orbitals they require electrons. So carbon is giving away one electron, like that's getting pulled. And so one of the orbital of nitrogen is already full because of the sigma bond that's being formed. Remember, the first bond is always a sigma bond. So carbon, one of the electron got pulled by nitrogen, the other electron got pulled by hydrogen over here. So two of the electrons, they went in different directions, and you start calling them sp hybrid orbitals because the electrons are now stretched in this direction and in this direction. The other two electrons are right now in their original orbitals, like the 2py, and there's the red orbital, which is the 2pz. Nitrogen also has identical orbitals which are 2py and 2pz. So there's a 2py and there's a 2pz as well. So when two of these orbitals they become parallel to each other, the 2py and the 2py would start overlapping. They would merge on the top and the bottom. And the 2pz and the 2pz are also in parallel, so they would also start overlapping in front and behind the axis. Abdullah, is this clear?
Yes, sir.
Similarly, what you just need to know is this is what carbon would look like when it's sp2 hybrid, when it's sp hybridized. One electron getting stretched. So one electron getting stretched in one direction, the other electron getting stretched in the other direction. So there's an atom X, there's an atom Y, and two of the orbitals are unchanged. So one on the z-axis and one on the y-axis. And these two orbitals would be involved in pi bonding. In carbon dioxide, something similar happens. In carbon dioxide, carbon has an oxygen on one side and another oxygen on the other side. So out of the 4 electrons, one electron gets pulled by one oxygen, the other electron gets pulled by the other oxygen. And oxygen, remember, has the outer electronic configuration is 2px2, 2px, one second. So the outer electronic configuration is 2px2, and it's 2py1 and 2pz1. So oxygen needs electrons in 2 of its orbital. Now oxygen did get 1 electron from carbon. So one of the orbital is full. The other oxygen also gets an electron, so it's one of the orbital is already full. Carbon has 2 spare orbitals now. 1 electron went here, 1 electron went here. So there are 2 electrons that are still available. No one is attracting those 2 electrons. So you have a 2py and you have a 2pz, which is lying on the z-axis. So oxygen has a spare orbital as well. It's got a 2pz. So this oxygen has a 2pz. So these two would start to overlap. And they're going to form a pi bond. That's the double bond that's being formed. So a pi bond would be formed over here. A sigma bond was already formed initially, but now you've got a double bond. Carbon had a spare orbital. Oxygen had an orbital as well that needed electrons, so they started overlapping. That's the same thing with this oxygen. This other oxygen also has a spare p orbital. Because it only received 1 electron, so 1 electron got filled up in the 2py, but there's another orbital that's already that still needs electrons. So that oxygen will have an orbital and it would overlap with carbon's orbital. And they would also start to form a pi bond. So 2 pi bonds would be formed by the spare orbitals of carbon. So initially they would form 2 single bonds, but then these spare orbitals would end up forming pi bonds. That's where the double bonds are coming in from. So there's going to be a double bond on this side and there's going to be a double bond on the other side. So carbon would be forming two double bonds. Initially it formed a single bond, one electron went here, one electron went over here. But then it had two spare orbitals, one overlapped with the orbital of the other atom, the other one overlapped with the orbital of the other atom, and they ended up forming two pi bonds as well. So there was a double bond here and a double bond that was formed over here as well. Is this clear?
Yes, sir.
Okay, so it's one second. Achha, so the main point is when carbon is sp2 hybridized, the angles are 180 degrees. Like one bonds forming on one side, bonds forming on the other side. So it's a completely linear molecule. Same is the case with carbon dioxide. Like if you have carbon dioxide, the angles are going to be 180 degrees. It's going to be I mean, all the atoms would be in a straight line. And linear means that they would be in a straight line. So this is example of sp hybridization. So what you need to know is whenever carbon is bonded to two atoms, that's sp hybridization. So I'll give you a question. Like you'll get questions like these. I mean, you won't be asked to draw them. For sp2, you might be asked to draw. Like the question on ethene comes very frequently. But you already see a double bond over here. So what you just have to do is you have to draw a single bond. That's a sigma bond. And then there's going to be a pi bond that would be orbitals overlapping above and below. But most of the questions are about just figuring out whether it's sp2 hybridization or sp or sp2. So for example, I have this molecule. That's a first carbon atom. What type of hybridization is this? Anyone? Carbon is bonded to four atoms. Anna, Nabila, Bob, what type of hybridization is this when carbon is bonded to four atoms? sp3, sp2 or sp?
sp3.
Okay, so I mean that's all you have to know. I mean it's going to be sp3. So you'll be asked what would be the shape. I will talk about the shape later. What type of hybridization is this when carbon is bonded to just three atoms?
sp2.
Okay, that's going to be sp2. And when carbon is bonded to just two atoms, that's going to be sp hybridization. So they might talk about shape. The first one, this one over here, that's going to be tetrahedral. So I mean, they wouldn't ask you to sketch the shape, but if I were to sketch the shape, it's going to look something like this. It's going to be tetrahedral, three hydrogens, and on the fourth side, there's going to be a carbon atom. And that carbon atom is going to be fan-shaped because it's only bonded to three atoms, so it's forming a double bond over here. And in the bottom, there's a C. I mean, this carbon atom over here. The second one, it's just bonded to three atoms. One on top, one over here, one over here. So it's going to be like a fan. All the angles are going to be 120. And the last carbon atom, that's going to be linear. The triple bond would be exactly straight. So angles over here would be 120 degrees. Angles over here would be 180 degrees. And angles over here would be 109.5 degrees. This carbon atom would be fan-shaped. This carbon atom would be tetrahedral. This carbon atom would be making an angle of 180 degrees. There's a double bond over here. That means out of the four electrons, three electrons got busy bonding. So I can even show you how a pi bond is being formed. Like carbon's three electrons are already busy. The fourth electron is available. And oxygen also has a spare orbital, and they would start overlapping. That's how the double bond forms. And over here, there's a triple bond. So that means out of the two electrons, one electron went here, one electron went and bonded with N. Carbon has two spare orbitals, and they would overlap above and below with the nitrogen atom. Is this clear?
Yes, sir.
Okay, so let's do past paper questions on hybridization. We'll also talk about shapes of molecules. Okay. Tomorrow, just remember the basic stuff. TK, you wouldn't be asked, especially for SP hybridization. That's the least important. You don't often get asked a lot of questions on this, but just remember what's happening. And what's the shape of the carbon atom? It's like this. Uh, Two of the orbitals are involved in pi bonding, and two of the electrons involved in normal bonding. Tetrahedral, and you've got this sp2 hybridization. Chaliye, let's continue tomorrow. Chaliye, okay, everyone, take care. Allah Hafiz.
Allah Hafiz.